Okay, we're now recording. Okay, but anyway, so going back to this, guys, be sure you guys know what each of these terms mean in these four major kinematic equations, because you're going to need this to work out several sample problems on the test. For the test that we're going to have on Monday. So remember, VF stands for final velocity, VI stands for initial velocity, A stands for acceleration, T stands for time, and of course, whenever you guys see D, that stands for distance or displacement. Okay, so keep that in mind, because you're going to need to know that for the test. Okay. All right, so guys, if you're at your computer, go ahead and open up the So go ahead and open up the assignment. Again, we're going to do this together. I would also be writing down what I'm going to be writing down on the screen, because guys, it's very important that that you take note of this, so that whenever you guys see these free fall problems on the test, you guys will know how to solve for them, because you guys are going to see free fall problems very similar to this. Okay. Now, guys, remember the questions are random. So basically, you just go to the questions that I'm at. The question that I want to do first is this one right here. Okay. I want to do number 3 first. Well, it's number 3 on my end. I don't know what it is on y'all's end. So, guys, go to the question that says an object is thrown 3 meters per second from the ground and it lands on the ground. Okay. It is your responsibility to put the answers in their correct order. Okay. So guys, let me draw a picture of what's happening here. Okay. So it says we have an object. Okay. It says our object is thrown 3 meters from the ground and it lands on the ground. So guys, we basically have a projectile here. We have an object. So imagine some sort of ball here. We have an object. It goes up, comes to a stop, and then it comes back down. Okay. So it's pretty much in free fall. Okay. Now, so okay. So VI says, what is the initial velocity of the ball? VF says, what is the final velocity of the ball? A is what is the acceleration, and then delta Y stands for basically the change in distance, or the change in, in other words, the displacement in the vertical direction. Okay. So guys, we have to put all of this stuff in order. The first thing we want to know is, what is the initial velocity? Guys, they actually give us the initial velocity. If you guys see that the ball is thrown at 3 meters per second, if you look at the units, 3 meters per second represents the initial velocity. So the initial velocity is just 3 meters per second. Okay. Now, okay, guys, as the ball goes up, comes to a stop, and then comes back down and lands on the ground, someone tell me, what is the final velocity here? Guys, think logically here. If the ball slowed down, came to a stop, and then speed back up again, just before it strikes the ground, what is its velocity here? You knew the moment the ball was released, it had a velocity of 3 meters per second in the positive direction. Can someone tell me what do you think its velocity is going to be as it's heading to the ground? What is going to be the velocity in the negative direction? Anyone? Well, guys, think about this. If the ball was released with a velocity of 3 meters per second, and it goes up and comes to a stop, exactly, it's going to be 3 meters per second, but in the opposite direction. So negative 3 meters per second is the final velocity. Thank you, Pablo. Thank you, Michaela. You guys are exactly right. Now, what else do we have to find? We have to say, okay, what is our acceleration? Guys, what is the acceleration of the ball acting under gravity? Y'all should know that. We said that plenty of times. If we ignore air resistance and acceleration, the ball's acceleration is just what? Yep. 9.8 meters per second squared. Okay. And lastly, guys, what is the ball's displacement? Remember what displacement means. Displacement means what is the how far the object is from its starting point. So solely looking at the vertical direction, guys, the ball goes up and then comes back to its starting point. So that means its total displacement must be 0, right? Because it came back to its starting point. Okay. So with that said, let us put everything in order. Okay, so number 1 represents our initial velocity. Okay, we just said that our initial velocity was 3 meters per second, guys. So, guys, for your answer, please drag that box to box 1 because you want to put everything in order. And then number 2, the second box needs to be the final velocity, which is negative 3 meters per second. Okay. And then number 3, the acceleration has to be negative 9.8 meters per second squared, and we already have that for number 3. And lastly, the displacement, which is delta y, is 0 meters. Okay. Okay. So guys, as soon as you guys got that as your answer, in that correct order, number 1, number 2, and number 3, and number 4. Let's go ahead and move on to the next one. Any questions before we move on? Again, so the initial velocity is the first one. The final velocity should be the second one. The third one should be the acceleration. And the fourth one should be the displacement, which is just 0 meters. Okay, so if you have your box in order, we're ready to move on to the next one. Okay. Okay, guys. We're going to go to the next ordering question. That looks like this. Okay, so let me clear this page so we can move on to the next one. Okay, so it says here an object is thrown into the air going 80 meters per second. How high does it go? Okay, so guys, we have an object here that's being thrown, and it goes straight up into the air, and obviously here it comes to a stop. Now the problem doesn't tell us that it came back down, so for right now we're just focused on well, I mean, we know eventually it's going to come back down, but right now we're just focusing on what's happening from here to here, you know, because it's going into the air. Okay. Now we have to put the things in order: the initial velocity, the final velocity, and the acceleration. Okay, so the initial velocity is easy. We know that the moment that the ball was released, okay, it has an initial velocity of 80 meters per second. Okay. And guys, what is the final velocity at the very top? In other words, someone tell me, what is the instantaneous velocity of the object here? Yeah, that's pretty easy. Anyone want to tell me? Remember, it goes up and it's going to slow down because gravity is acting on it. So if it's slowing down, when it reaches the very top, what is going to be its instantaneous velocity? Yep, thank you, Michaela. It's going to be 0 meters per second. And of course, the acceleration at every point is always 9.8 meters per second squared at every point. Okay. So with that said, guys, let us put everything in order. Okay. So for number 1, we want our initial velocity. Remember, our initial velocity was 80 meters per second. Okay. For number 2, we want to know our final velocity. That's the second thing, which is the velocity at the very top. As Michaela said, it's just 0. And lastly, the acceleration is negative 9.8 meters per second squared. So there we go, guys. Everything's in order. 80 meters per second. 0 is the second one listed for the final velocity. And then lastly, the acceleration is negative 9.8 meters per second squared. Okay. So guys, if you have that in that order, you're done with that problem. Okay. Everybody got that? Everybody got that? Okay.
Can you go to the other one that was like this one?
Yep, here it is. Can I move on?
Yes, sir.
Okay. Now let's look at number 1 here. Okay, guys, so we got 4 more to do. Okay. Now here we're getting to the calculations part of it. Number 1 says a person throws a tennis ball 6 meters per second straight up. How long does it take for it to come back to their hand? Okay. So guys, we're going to actually have to solve this problem in 2 steps, really. First thing that I want to do, I want to draw out what they're saying. So, hold on, let me clear this. Okay, so guys, if we have a tennis ball here, so we have a tennis ball. So we have a tennis ball, and it says that the person throws the tennis ball. It goes straight up. The tennis ball goes straight up. Then obviously it's going to come to a stop briefly, and then it's going to come back down, and it's going to land back in their hands. Okay, so that's the motion of the tennis ball. Okay. Now it says the person throws a tennis ball with an initial velocity of 6 meters per second. Okay, and we want to know how long does it take for it to come back to their hand. Okay, so guys, there's 2 things we need to do here. Okay, the first thing we need to do, we need to figure out how long it takes for the tennis ball to go from here to here till it reaches the very top. Because once we find that, then the second step, we can easily find out how long it takes to come back down. Okay, so the initial velocity of the tennis ball is 6 meters per second. Okay, so I'm gonna write that here. So the initial velocity of the tennis ball is equal to 6 meters per second. Okay. Now, someone tell me, what is the final velocity of the tennis ball at the very top? It's just 0, right? Because thank you, Michaela. The instantaneous velocity is 0 because it comes to a stop. Okay. So in other words, we have all the information we need to find the time it takes for the ball to go from here to here. So guess what equation we're going to use to solve for that? We're going to use this first equation here. Final velocity is equal to initial velocity plus acceleration times t. Okay, so we're going to use this first equation. So I'm going to write that down. Final velocity is equal to initial velocity plus acceleration times t. Okay. Okay. So guys, remember, we're taking this problem in 2 steps. The first thing we're doing, we're solving for the time it takes to get to the top. The final velocity at the very top is 0. Okay. The initial velocity, and guys, direction here matters. The initial velocity is positive 6 meters per second. So positive 6 meters per second. Okay. Okay. Guys, what is the acceleration of the tennis ball? Y'all know this. I've said it over and over again.
Negative 9.8.
Yep, negative 9.8. Please embed that in your brains, guys. It's a very common number you need to know. All right, so now, guys, we need to solve this equation for t. Okay. Y'all follow me? How do I get t by itself? First thing I need to do, I need to take 6 and move it over to the other side of the equal sign. So in order to move it over, guys, what I need to do, I need to subtract 6 here. That goes away. Whatever to do to one side, I have to do to the other. So I'm just left with negative 6 equals negative 9.8 times t. Okay. Hopefully you guys are following me. Now, from here, guys, how do I solve for t? Y'all, come on now. I know y'all know algebra. Y'all have to know algebra because y'all going to be doing algebra on this next test. Yes, divide by both sides. Thank you. How do you say your first name? Is it Zalaria? Am I saying that right?
Yes.
Okay.
Mm-hmm.
Thank you, Zalaria. So it's divide by 9.8. That goes away. Whatever to one side, I have to do to the other. So, guys, negative 6 divided by negative 9.8 gives me 0.621. I'm sorry, 0.612. What did I say? Seconds. But guys, I want to tell you something. We're not done. This time here, 0.621 seconds, that's the time it takes for the ball to go from here till it gets to the very top. We want to know the total time that it's in the air just before it reaches its hand. So someone tell me, guys, if we know the time from here to here, for the second and the final step, how do we find the time it takes to go back down? In other words, the total time from here to here. Y'all, guys, use logic. If you know that it takes around 0.6 seconds to go from here to here, how do you find the total time for it to go back the other half of distance? I mean, the other half. Guys. Anyone? Guys, I'm going to say this again. If you know the time it takes for it to go from here to here, how do you find the total time that it takes to go from here all the way to here? You just multiply what? By what? Well, guys, we're going to take this number and we're going to multiply it by 2. Because think about this, guys. This here, from here to here is half the distance. So if this here is for half the distance, in order to find the total distance, we just multiply that number by 2. So guys, when you take that number and multiply it by 2, what answer choice do you get? Out of this, and this. Thank you, Michaela. Yep, 1.2 seconds. Any questions before I move on? Okay, we got 3 more. Okay, let's kind of make this quick. Okay, guys, for this next question, it says a ball is thrown 2 meters per second into the air. How high does it go? Okay, so let me open up a new sheet. Okay. So a ball is thrown straight up into the air. Its initial velocity is 20 meters per second. How high does it goes? So we have a ball. We throw it straight up into the air. Okay. We're also told the initial velocity. The moment the ball was released, it had an initial velocity of 24 meters per second. Okay. And if we're asking for how high does it goes, we're basically asking for the displacement or the distance from here to here. So we're solving for D. Okay. Guys, you also know the final velocity at the very top. Think logically. If the ball goes up and gravity acts on it, it's going to slow down and come to a stop. So the final velocity at the very top is just 0. Okay. You guys also know the acceleration. The acceleration is just always negative 9.8 meters per second squared for object in free fall. Okay. So with that said, guys, let us look back at our equations here. And so let's see which equation to use. So okay, guys, it turns out right now that I'm going to use this final equation here. I'm going to use this equation here because I'm not going to use any of these equations at the top because time is not important in this problem. So I need to use an equation that doesn't have time. So I know the final velocity, I know the initial velocity, and I know the acceleration. So therefore, I have everything I need to solve for the displacement. Okay. So I'm going to use this equation here in green. Okay. So, and again, guys, if I were you, I would write all these equations down because you will have them available for you guys so you can use them on the test. So use that equation green. So final velocity squared is equal to initial velocity squared plus 2 times acceleration times distance or displacement. Remember, I'm solving for distance here. So, guys, I already know the final velocity. The final velocity at the very top was just 0. So, remember we said the final velocity at the very top is just 0 because it has to come to a stop before it comes back down. So, 0 squared is equal to my initial velocity. Well, my initial velocity is 24 because we were actually given that in the problem. So 24 squared. Okay. What is the acceleration of gravity? You guys know that the acceleration of gravity is just negative 9.8. Okay. All of this times my displacement. Okay. So guys, the rest is easy. I can just rearrange this equation and solve this equation for displacement. So let's go through the algebra. Everybody know that 0 squared is just 0. Well, what is 24 squared? So 24 squared is 576 plus. Okay. Now guys, before I can solve anything, I want to take 2 and multiply by 9.8. So 2 times 9.8, or 2 times negative 9.8. That gives me, that basically gives me a negative 19.6. All of that multiplied by D. Okay. So guys, the rest is just algebra. Okay. So guys, what I want to do, guys, see this 576? I want to get rid of it, so I want to subtract it to the other side of the equal sign. So negative 576, that goes away. Whatever I do to one side, I have to do to the other. Negative 576. So I'm just left with negative 576 is equal to negative 19.6D. Okay. So you guys tell me, what is my final step? How do I solve for the displacement? How do I get D by itself? I divide by 19.6. That goes away. Whatever I do to one side, I have to do to the other. Okay. So guys, go ahead and do the math there, and then that should be your answer. Okay. So I'm not going to yell out the answer for you guys. I want you guys to find it. Well, Michaela already did. But thank you, Michaela. So, okay, y'all got that? No, you're good. You're good. You're fine. Okay. All right, guys, 2 more, and then we're going to call it a day. 2 more. Let me just erase this. Give me some extra blank pages. Okay, this problem right here says an object is thrown into the air going 9 meters per second. How fast is it going 2 seconds later? Okay. So, guys, this problem here, I don't really need to draw a picture. I basically just need to plug everything into the equation and solve for it. So, an object is thrown into the air going 9 meters per second. How fast is it going 2 seconds later? In other words, we're asked to solve for the final velocity. So for this problem right here, guys, we're going to use this first equation here. Final velocity is equal to initial velocity plus acceleration times time. Right? Because we're given the initial velocity, we know the acceleration, we know the time is 2 seconds. We have everything we need to solve for the final velocity. So I'm going to write down the first equation. Final velocity is equal to initial velocity plus acceleration times time. Okay. So we're trying to solve for the final velocity. In other words, we're solving for the final velocity after 2 seconds. So that's what we're solving for. So the final velocity is equal to the initial velocity. The initial velocity is 9 meters per second. And of course, it was thrown upward, so it's moving in the positive direction. So we know the acceleration is negative 9.8 meters per second squared. And we know the time is 2 seconds. Okay. And now solve for the final velocity. Okay. Now, guys, I'm not going to do this one for you. You guys should know how to do it. If you want, guys, you can work it out and then send me a private message, and I can verify it for you. But that's super easy. You have everything you need to solve for the final velocity. Okay, guys, take about 30 seconds to do that. And it's if you guys get the answers, you can send me the you can ask me privately, and I can verify that you did it right. All right. Anybody else before we do the last one? Okay, last one. An object is dropped from a 15-meter ledge. How fast is it moving just before it hits the ground? So here I'm going to draw. Excuse me. I want to draw a picture first, and then I'm going to set it up, and then I'm going to have you guys work the algebra out yourselves. Okay. So according to this problem here, we have a ledge. So let me kind of draw a ledge here, basically a high place. So here's my ledge. You know what? You know what I should have done? Let me just make my ink thicker. So we have a ledge here. And it says an object. So like imagine a ball being dropped off this ledge. So we have a ball. And it's being dropped off the ledge. And it falls all the way down to the ground here. Okay. Now, the height of this ledge is a total of 15 meters. So, because that's where we're told in the problem. And we want to know what is his final velocity just before it hits the ground. Okay, that's what we're trying to solve for. We know the acceleration is 9.8 meters per second squared. Okay. Well, negative 9.8. Here sign is important. Okay. Now, guys, can someone tell me what do you guys think the initial velocity of the object will be at the very top? Remember, what is the initial velocity just before it's released? The initial velocity is just what? We're going to assume the initial velocity is 0. Have I got that? So the initial velocity is 0. Okay. So guys, with all this information that I have drawn for you all, it should be easy to know which equation to use. We know the displacement. In other words, the height of the ledge is 15 meters. We know the initial velocity. We know the acceleration is negative 9.8 meters per second squared. That's always our acceleration. And now we've been asked to solve for. We've been asked to find the final velocity. So guys, the equation that we need to use here is going to be this last equation here. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. And again, we want to, our goal is to solve for final velocity. Okay. Okay. So guys, let's go ahead and set everything up. So final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. Okay. Final velocity squared. Okay. Remember, the initial velocity is 0. So obviously 0 squared is just 0. Okay. Guys, I'm gonna put everything here in parentheses. So 2 times negative 9.8, which is the acceleration, times the displacement. Remember what we said? The displacement was 15 meters. Okay. And of course, I'm going to put all of that in parentheses. So 2 times negative 9.8 times 15, 0. And guys, your goal is to solve for final velocity. You're not solving for final velocity squared. You're solving for final velocity. Okay. So I'm going to have you guys go through the algebra, work that out, and then send me a private message when you think you have the answer. Hey guys, one thing that I want to say, in order to make sure that your calculator gives the right results, whenever you take the square root, go ahead, just pull that negative outside of the square root, so that you can, so that your calculator will be able to take that problem, plug it into a system, and give you the right result. Hey guys, I want to say something here from the private messages you guys were sending me. A lot of you guys are forgetting to take your square root, because like, remember, this is final velocity squared is equal to, remember, 12 times negative 9.8 times 15 gives me a negative 294, right? Okay. But guys, look at this right here. This is final velocity squared is equal to 294. We want to know what is the final velocity. So guys, how do I get rid of that squared, guys? I do what? I just take the square root. So I take the square root of that. Whatever I do to one side, I have to do to the other. So final velocity. And again, guys, whenever you put in your calculator, just pull that negative outside of the square root. That way you'll be sure that your calculator gives you a real solution. So when y'all do that, can y'all send me a private message now telling me what y'all got? Guys, remember to pull that negative outside of your square root. Now, the negative is important because remember, the negative just tells you the direction the object is traveling. But if you want your calculator to give you a real solution, just do negative. I mean, you just do square root of 294, and of course, the negative tells you that it's moving in the negative direction. And guys, that actually makes sense because since the ball is moving downward like this, just before it strikes the ground, you should expect it to have a negative velocity. Okay. All right. Any questions before I end the Zoom call? Any final questions for me? Okay. So remember, guys, in Schoology, if you have time today, I will highly recommend that you guys get started on this review sheet. Because remember, the common assessment is going to cover information from both the past 6 weeks and also this 6 weeks as well. Administration made us do that. They made us, cover both 6 weeks into this, to this one common assessment. So this review sheet goes over all the information. Guys, remember, class time is not required on Monday. However, I'm going to have the Zoom open available in case you guys want to log into the Zoom session and ask me any questions before that. Before you take the test, in case you guys have any questions over anything that comes from the review sheet. Okay. So again, you're not required to come to class, but just know that I'm going to have the Zoom session open. Also, I'm going to, and hopefully sometime before this weekend, these first 5 questions I'm going to work out online, and then I'm going to post a video on YouTube so you guys can go and watch how to do those questions for the review sheet. Now, this final exam, not this final exam, but this common assessment exam is going to be different from last time. Last time, y'all took it in All in Learning, but this time, administration is making us give it in Eduphoria. So I'm going to post the instructions to Eduphoria sometime in the coming days. Please read over those instructions. Please read over those instructions so that you guys will know how to access Eduphoria. Well, access the exam in Eduphoria before Monday. Okay. Yes, next Monday is the test. Next Monday is the test. Remember, you're not required to come to class on Monday. But I am going to have the class open in case you guys have any questions with either the review sheet or questions involving how to access Eduphoria. Okay. If there are no more questions for me, you guys are free to go. I hope everybody have a good afternoon and a good rest of your morning. Bye, guys.